right, well, let's go ahead and continue our discussion of oblique triangles. And I said we kind of wrapped up law of sines in our last lesson, but we're not done with triangle cases. Our first lesson of the semester, I discussed 5 different triangle cases. I said when we prove triangles congruent in geometry, we had side angle side, theorem 1, flashback. Theorem 2 is angle side angle. I think theorem 6 was side side side. Side angle angle actually came, I think, as one of the corollaries of theorem 11. And then side side angle was that weird one, remember, we showed in a construction couldn't work, okay? And so we've looked at the 2 angle scenarios, and we've looked at one of our 2 side scenarios where there was an opposite side, and there was that ambiguous case. But for all of these, the law of sines worked. For side angle side, which means side, side, angle in the middle, so no matching letter. If this is side A, side B, that's going to be angle C, right? No matching letter. For side angle side, or for side, 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 all 3 sides, that's not going to work in the law of sines. Think about it. If you have all 3 sides, that gives you all 3 numerators, correct? But no denominators. And not an easy way to get a denominator. You got to have something, right? All 3 denominators is no good. That'd be angle, angle, angle. That proves similarity, not congruency. Side, side, side. Similarly, you got all 3 numerators, but no denominators. That's not helpful. Also, side angle side is no good. Let's say you have these 2 sides, then it would be this angle. But you don't have a complete ratio. And without Pythagorean Theorem, because it's not a right triangle, it's an oblique triangle, you can't find the 3rd side. But only one angle isn't enough to figure one of the other 2. So for side angle side and side side side, the law of sines is just insufficient to solve. But we've got another law that we can use, something you would recognize from physics as well, and it's the law of cosines. Now the way I've got it on the poster is a squared equals b squared plus c squared minus 2bc times the cosine of a. The way I taught it to you in physics is the way I want you to write it down in your notebooks now for the law of cosines, and it starts out the same as the Pythagorean Theorem. C squared equals a squared plus b squared minus 2ab times the cosine of angle C. Now you say, that looks an awful lot like the Pythagorean Theorem. Well, let's think about a right triangle. If you know the 2 legs, A and B, and are finding the hypotenuse C, that is side angle side, because what's the included angle between the 2 sides, between the 2 legs? A 90-degree angle C. What's the cosine of 90? 0. So this all becomes 0 in the Pythagorean Theorem, which just leaves us with this part that we call the Pythagorean Theorem. So in a sense, you could say that is kind of the Pythagorean Theorem, just with a little bit of extra. Now I want you to notice the pattern here. C squared equals the other 2 squared added minus double the product of these same 2 letters, A and B, times the cosine of the angle that's opposite this side. The way I've got it here, a squared equals the other 2 letters squared minus twice the product of these same 2 letters times the cosine of the angle opposite this. So if I were to say b squared equals, how do you suppose I would write the lettering for the others? Okay, I would have to go a squared plus c squared. Okay, the other 2 letters would go here. And then how would I finish the rest of it? Jamie, take a stab at the rest.
Minus 2 AC.
Good, these same 2 letters again, but now multiplied.
And then the cosine of b.
Good, the cosine of the angle opposite this side, cosine of b. So you can use the law of cosines to solve for any side that you need. And in a side angle side triangle, there will only be one side you're missing. In a side 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 triangle, you're not going to have to solve for any sides. So this particular formula, you'll use once or not at all. What are you really missing with the law of cosines? You're missing a bunch of angles, right? Here you'd be missing all 3 angles. Here you're missing a couple of them, right? So let's look at manipulating this equation to get the letter by itself. Supposing I wanted to get, for instance, angle C by itself. Well, I would take this entire chunk here, since it's negative, and double swap it with the c squared, which would give me, don't write this down yet, 2ab is equal, or 2ab times the cosine of c is equal to a squared plus b squared minus c squared. So far, so good. So follow. Then if I divide away the 2ab and take the arc cosine of both sides, I want you to write this down. C equals the arc cosine of a squared plus b squared minus c squared all over 2ab. And this is what we're going to do, frankly, most of the time as we solve law of cosine triangles, side angle side or side side side, because most of the time we're looking for angles. 2 out of 3 angles or all 3 angles. Well, we could redo this for angle B, the same thing. We could say B equals the arc cosine of the other 2 letters, a squared plus, that's a squared, plus c squared, minus the matching letter b squared, all over twice the first 2 letters, 2ac. Same thing, just rearranged. So if I said a equals, what would it look like, Quentin?
Cosine times
Of
b squared plus c squared minus a squared all over 2 bc.
There we go. And if you can memorize the pattern to it, that'll get you whatever letter you want. These are what we're going to use most of the time, frankly, in law of cosines. Questions on this? All right, so let's actually look at a side angle side triangle. Write this information down if you would. If we know that angle C is a 38-degree angle, if we know that side A is 12 inches, and we know that side B is 19 inches. Now again, building on what we've done before, I always approach and say, what case do I have? Well, clearly we're given, class, 2 sides and 1 angle. But there's not a match. Side-side angle has a match that's called the opposite. The non-match is the adjacent. Here there's no match. These are both adjacent, which means this is not side-side angle. It is side angle side. And frankly, as long as it's not a reflex angle, we got a triangle. Right? The only way you wouldn't get a triangle out of this is if I gave you like a 185-degree angle. You're not going to be fooled by that, so I'm not going to do that to you, okay? So we got a triangle. And so we're going to start off by solving for the one missing side. You might want to jot that down. In side angle side, always start by finding the missing side. You already got 2, you might as well get the 3rd. The missing side here, of course, is side C. So we're going to go to the law of cosines that's set up for side C. That's this one here. But this is actually c squared. I just want c. So I'm going to end up having to take the square root of all of this. You two both have the same calculator I do, and it's an indirect entry. So what we'll do is we'll enter all of this first, then take the square root at the end. So on your calculator, let's start with a squared plus b squared minus, and then hold off. You're going to want to put all of this in parentheses. So you see your parenthesis key above the 8. So we got the a squared plus b squared minus, now hit the parenthesis after you hit the minus, parenthesis, and notice the calculator clears off because it's about to store parenthesis values. 2 times a times b times, and remember for us, we don't do cosine of 38, we do 38 cosine. Make sure you're in degree mode. 38 cosine, then close that parenthesis. But what you see on your calculator right now is this. You're going to have to hit the equal sign in order to show the full radicand. So now hit the equal sign. That's your radicand. Now we take the square root. Really, the key to this is calculator entry, being careful how you enter it. We should have gotten 12.069 blah, 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 which rounds to approximately 12 inches. So far, so good? Let's run through it one more time for practice. Because again, really, truly, this is easy if, number one, you have the formula memorized. Number two, you can plug it into the calculator. And the calculator is the tricky thing. All right, so let's start with a squared plus b squared minus parenthesis. 2 times a times b times angle cosine close the parentheses, hit the equals, then hit the square root. Still got the 12.06, blah, blah, blah. Now, write this in your notes. This has got to go in the memory. Kind of like on the double triangle, that first thing you find has got to go in the memory. On a side angle side, the first side you get must go into the memory. I will say this. Throughout my 12 years of teaching pre-cal, I guess 11, this is year number 12. Throughout my 11 years of teaching pre-cal, when we get to this, I can tell when a student forgets because I hear this noise. They're working through the problem. Now I've got to re-enter the whole thing again, right? Put it in the memory because you're going to need C to solve for angles A and B. Look, there's a C squared in both angle A and B. You have to have side C, and it's got to be in the memory, so put it in the memory. Now that we've got that, we can solve for either angle, and Jamie, which angle do you want to solve for first? A. She's a conventionalist. Angle A comes before angle B. Let's just do angle A. So, we've got it side C in the memory, remember. I'm going to put a little M1 here, since normally I don't have the word memory written next to it. And we'll start off for A. Now remember, for the angle, this is going to be last, because we're indirect entry. If you're a direct entry calculator, start with arc cosine. There you're going to need some parentheses in there. So again, if you need help with this, if you're like, I'm not getting these, pause the video, wait till I help you, then come back and try to finish it. No sense being frustrated the whole lesson, all right? But I can help you on video chat if you're struggling. All right, so we're going to start with the b squared. So that's 19 squared, plus, memory squared minus a squared. And then I'll do an equal sign at the end of this to get my numerator. Got your numerator? 362.66? All right, now, to me, the easiest way to do this is to divide away the 2, then divide away the b, then divide away the c. You could do divided by parenthesis, 2 times b times c, close parenthesis, equal. But that takes too long. I want the fewest keystrokes possible. I am that lazy. So I'm going to say divided by 2, divided by b, divided by the memory value, equals. And we should have a decimal on the calculator now, 0.790. Now, take the arc cosine. And we don't have to put this in the memory. What do we get for our angle?
37.74.
37.74, which rounds to what?
38.
38 degrees. You say, wait a second. A is 38 approximately. C was 38. Yeah, look at sides A and C. They're both about the same, so it makes sense they'd be about the same. By the way, C, remember, was a tiny bit bigger. It was 12.06, right? Which means angle C is a tiny bit bigger. This isn't quite 38, it's 37.7. It's a little smaller because this is a little smaller. So far, everything's making perfect sense. Now, we solve for angle B. The lazy man way to do this is to add A and C, subtract from 180. But if you do that, you have no way of checking. So if you're really strapped for time and you want to gamble that you got this right and this right, you can. But my recommendation would be solve angle B the hard way so you know at the end of the problem, I'm perfect. So let's go ahead and do angle B the hard way. Let's start with a squared plus c, which is memory, squared, minus b squared equals. Notice you have a negative value. That's okay. Then divide away the 2, divide away the a, and divide away the c, which is the memory. You still have a negative. It's a decimal, though. That's okay. You can take the arc cosine of a negative. It's going to give you an obtuse angle. Of course it's going to be an obtuse angle. I have less than 90 degrees so far. Take the arc cosine. What obtuse angle do we get? 104.25, blah, blah, blah. Now the sig figs here are annoying because we have to say 1.0 need 2 degrees, but it's really 104, right? That's what we would have gotten if we'd subtracted the 76 from the 180. But because I got 104, I am confident my answers are right. Whereas you accidentally screw something up, now you got all 3 answers wrong, and I have no pity. Because I told you to do it the hard way to make sure you could check. Okay, so questions on this? All right. Do we feel like we're getting the hang of the calculator entry? All right, let's do another one. This time let's do a side, side, side triangle. And it's easy to spot side, side, side. I mean, can't possibly mess it up. I guess the only way I could mess it up is if my two littles were smaller combined than the big. But they're not. So this is a real triangle. Notice all the angles are missing. Angle A, angle B, angle C. But here's the nice thing. To find an angle, you gotta have the sides. They're already there, no memories needed. I actually really like side, side, side. I don't have to use the memory one time. So, let's find angle A. Let's be conventional here, right, Jamie? Let's start by solving angle A. So b squared plus c squared minus a squared equals, divide out the 2, the b, and the c, equals, take the arc cosine. 11 squared plus 17 squared minus 15 squared equals 2 divided by 11 divided by 17 equals arc cosine. How big's the angle?
60.35.
Good, 60 degrees when we round. All right, now for angle B. A squared plus c squared minus b squared equals, divided by 2 divided by a divided by c equals arc cosine. How big's angle B?
I'm trying to get it.
It's okay. Appreciate Quentin being a gentleman and saying, I'm going to let the lady answer this one since I took the last one.
I got 39.4.
I had 39.59.
I'm not quite sure, but
All right, try it again. Starting from scratch. We're in degree mode. Good. All right, so start with the, so since we're finding b, and we're going to do a squared plus c squared. So a squared plus c squared minus b squared equals, divide away the 2, divide away, you don't have to do equals between those, divide away the a, divide away the c, equals, now take the arc cosine. There it is. All right, and we should get 39.59, or round in 2 sig figs, 40 degrees. Now, we know what angle C ought to be. What should it be, rounded? 80 degrees, right? But let's just make sure we didn't screw anything else up. Let's go ahead and find angle C the hard way, and if it comes to 80, I know I'm golden. If it doesn't, then I'm like, ooh, either I messed up C or I messed up one of these, okay? So, find C at your C's. And sure enough, 80.05. 3, 5, 7, blah, blah, blah. Rounded, 80 degrees. And we know we're in good shape. Do we see how to solve side, 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 and from the previous side angle side? The key is have the formula, the law of cosines, memorized. So let's see how we do when they're not written on the chalkboard. And we may have to write them for ourselves. Write this down if you would, please. Angle B is a 105 degree angle. Side A is 12.3 centimeters. And side C is 7.85 centimeters. First of all, what case do we have?
Side angle, side.
How do we know it's side angle side?
2 sides, 1 angle, and neither of them match.
Good, 2 sides, 1 angle, there's no match. I know it's side angle side. As long as it's not a 100 degree angle or bigger, I know I got a triangle, I got a triangle. First thing we got to solve for in side angle side is always the missing side. And when we get it, we have to put it into memory. Now I say that for my benefit, because I'll tell you in 11 years, I've forgotten to put in the memory a number of times, and then I go, oh. Okay, so I'm right there with the students feeling the pain sometimes, because I'm human too. All right, so let's find side B. What formula that's similar to this one do I need to find side B? Quentin.
Alright, B equals 2 AC cosine B minus A squared.
I think you just left off the a squared. Okay, so b squared,
Oh, I see. Yeah.
we're just going to put a b here and the other two letters here.
Yeah, you just switch them.
So b equals a squared plus c squared minus 2ac cosine b, but we're going to have to take the square root of all of that. Remember, parentheses here and here, and an equal sign before you take the square root. Again, direct entry people, you can do it that way, but you're going to have to do square root of answer, or you can try to enter it straight up. It's just, a little more obnoxious. As long as you're getting the correct answers, direct entry people watching, no big deal. If you're not getting the right answers, make sure I can help you figure it out before you try to do the rest of this lesson, or you're going to be frustrated for no reason. Okay, so and what do we get for side B?
I have 16.2.
Round it off.
16.2.
But put it into memory. It makes sense, by the way. It should be bigger than the other ones, shouldn't it? Because they got the obtuse angle. Of course this has to be the biggest side. But it can't be as big as, say, 20, which is about what these two would be together. It's got to be smaller than 20, but it's got to be bigger than the others. And it is. So far, I feel like my answer makes sense. If your answer is obscenely huge, for instance, I've had students put down 262. What in the world? That doesn't even make sense. If it's obscenely huge, you forgot to take the square root. And that's an easy solution I get all the time. My answer doesn't look right. Yeah, it's way too big, isn't it? What'd you forget to do at the end? Oh yeah, square root. But on a quiz or test, I can't do that for you. So if you see an answer that's huge, square root, that's right. And it gets it right where it belongs. If you get an answer that's obscenely small, you might have double hit square root, but I doubt it. Why you double hit square root, I have no idea. I've never actually seen that. But an obscenely huge number, you forgot the square root. Are you good on 16.213? All right, now that we've got it in the memory, yes, before we proceed, let's find angle. We'll let Quentin pick. Angle A. He's going to be like, I'll go along with the convention here. All right, so I want to solve for angle A. Remember, we're going to take this whole thing and swap places with the a squared and then get the a by itself. What does the formula look like when I say a equals, Jamie?
The arc cosine of would be b squared plus c squared minus a squared all over 2bc.
Good. The other two squared and added minus the square of the match divided by double the product of the other two. All right, remembering that b is in the memory. Of course, c and a are spelled out for you. Let's find angle A. Call it when you've got it.
47.1.
Rounded.
47.1.
All right. Remember, b memory squared plus 7.85 squared minus 12.3 squared equals, divided by 2, divided by b, divided by c, equals, and then finish with the arc cosine, if you're an indirect entry like I am. All right. Now, let's find angle C. What's that formula going to look like, Quentin?
C equals arc cosine of a squared plus b squared minus c squared all over 2a.
Good job. Rattled it off there with confidence. You cheated and looked at your notes from last time, didn't you?
No.
I'm just kidding. All right, find angle C. And call it when you've got it. Good, 27.88, blah, 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 rounded. 27.9 degrees. Now, check your three angles. Do they add up to within a degree of 180? They won't always add up to 180 because of weird roundings and stuff, but as long as they add up within a degree of 180, one way or the other, you should be good. Do they? In fact, they add up to, even the rounded numbers add up to exactly 180. Now, unrounded answers, if you decided to store them in the memory, should all add to exactly 180. Sometimes the way roundings work, it may round up to within a degree or so of 180. But if it's right in that neighborhood, you're good. Because again, if you screw up in this, you're going to screw up so bad, it's not even going to be close. Okay? The other way you can check, of course, is definitely by far the smallest side, by far smallest angle. Biggest angle, biggest side, everything makes sense. Okay? Questions? All right, let me give you a side, side, side. Nice thing about side, 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 don't have to use memories if you don't want to. Let's suppose A is 2.00, B is 3.00, and C is 4.00. Again, as long as the two littles add up to more than the big, we're good. And they do. So we get a triangle from this side, 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 easy to identify triangle. What do we want to solve for first, Jamie?
We want to solve for
angle A. I was like, is she going to look dangerously? She's like, angle B. No, angle A. All right, what's the formula for A, Jamie?
Is it like SA equals cosine?
Well,
arc
cosine
of
the other two.
B squared plus C squared minus A squared all over 2BC.
Perfect. That seems. And you don't have to do the .00s, obviously. Those are there to make sure you get 3 sig figs in your angles. Just do 2, 3, and 4 for now. All right, so 3 squared plus 4 squared plus 2 squared equals angle A.
28.15.
Rounded.
30.0. Or 29.0.
29.0 degrees. There we go. Waiting for a nod from Jamie. All right. Angle B. What's the formula, Quentin?
B equals arc cosine of A squared plus C squared minus B squared all over 2 AC.
All right. Again, if you're at home working on these, make sure you are answering along with me. Or maybe pause the video before I write it down, see if you can write it down first without looking back at your notes. Right, edge seats. All right.
46.567.
Round it off.
46.6.
All right, good to go. All right. Angle C. Formula, Jamie.
C equals arc sine.
Ooh.
Right.
Law of cosines.
Alright, cosine.
All right, cosine. There we go. That would be a bummer. And that would, by the way, that would definitely throw your angles off, right? So that's one of the reasons we like to have a check. Because how easy would it be to accidentally slip into the sine button instead of the cosine button? All right?
Is A squared plus B squared minus C squared all over 2 AB.
There we go. And what doth we getteth?
104.4.
0.47, blah, 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 rounded off. 104 degrees. Now here's a classic example. If you were to add the rounded angles up, they wouldn't hit exactly 180, but they'd be really close. If you were to add these numbers, they would hit 180. Well, the exact values would. These would be really close to 180 again. But these numbers, they're going to add up to, what is that, 179.6?
180.07.
Those add up to 180.07?
Oh, well, I did the rounded answer on the last one. Or not rounded, but...
Oh, you did the exact on the last one. Okay, gotcha, yeah. So, because again, this rounded up, this rounded down, but if you take... So anyway, yeah, but again, it should add within a degree. And if it does, you're in good shape. If it's more than a degree off, something's wrong somewhere. Questions on this? Feel like we got it? All right, turn your books to page 169. Do numbers 1 and 2. Page 169, do numbers 1 and 2. If for some reason you don't have your book at home, that's okay, because I'm going to put them on the chalkboard in just a second. They just get a head start, but you can pause the video. They can't pause me. Jamie's like, is that a challenge? Actually, I can't see Jamie saying that. But. finished? Jamie, still finishing? Okay, just another minute, and we'll go over answers. All right, let's go and take a look at the answers, and then Jamie, I'll see if I can give you some help here, but we do want to go ahead and move on if we can. Number one, the first thing you, well, actually you could have found any angle in any order. So Quentin, what was your angle A?
42 degrees. 42
degrees. Your angle B, Jamie?
64 degrees.
And angle C then should have been class 74 degrees. So we're good to go on the first one. It's 42, 64, and 74 degrees respectively. On number two, the first thing we had to find was the missing side A. If we screw that up, everything's wrong. Jamie, what did you have?
I have 1.7223.
Okay, that's correct. 1.7, your rounded side A. All right, using that side A, you could find side B, or angle B to be what?
120 degrees.
Rounded 120 degrees. We good on B. And then that leaves angle C. We didn't quite get that far, did you?
I didn't get that far.
Did not get that far.
27.
27 degrees should have been your angle C. So Jamie, maybe do angle C real quick and make sure you got that. So again, missing side A, 1.7, angles B and C, 120 degrees and 27 degrees respectively. Tell you what, I'm going to go give you your homework, and you'll have a little time in here to work on it. Homework for this evening is to do page 169, numbers 3 through 6. Page 169, numbers 3 through 6. That'll give you practice with 2 sides and 2 side angle sides. I recommend copying out the law of cosines as you do each of these so that we get practice copying it, especially on the side angle sides. The sides, maybe not as important because it's just the same angles over and over again. But the side angle sides, maybe just copying out those law of cosines. All right? You have a few minutes before the bell rings to get started. Go ahead and work on those.